All right, guys. So, in preparation for your test tomorrow, I am recording a video where I work the rest of the math from your work packet that we didn't get to in class, and then I'm going to work the math that's on the review itself. Try not to freak out too much about the math because everything we've done in this unit is just one part of the test. So the diagrams are one part, the conceptual types of mirrors, what kinds of images those types of mirrors make, and then the math. Each of those is just one component of the test. So don't get too stressed out about any one component. But let's see if we can kind of clear up some of the issues people are still having with the math. So starting on page 5 in your packet, I'm going to look at problem number 1. This one says that light travels through a sheet of crown glass with an angle of incidence of 30 degrees. If the angle of refraction is 19.2, what is the index of refraction for crown glass? So, our setup here is the mirror, which is our principal medium, the glass, which is our refractive medium, and it is coming in and incidentally so I'll put that here. And it's bending towards the central line for refracted angle 19.2. That over here as well. And then last but not least, for glare, and then is 1. And then R is what we're looking for. So we're going to use Snell's law in our science data science, and our science data. So that's 1 times sine 50 equals NR. You'll need to make sure your calculators are in degrees and not radians. So the sine of 30 is 0.5. The sine of 19.2 is 0.33. So R is 0.5 divided by 0.33. 4 and answer of 1.52. It doesn't have any units because n is the index of refraction, which is just a ratio. This number makes sense. The number should always be greater than 1 because it's representing how much light is slowed down. And in this case, it should be greater. Yeah, it just needs to be greater than 1. All right. The index of refraction for ethanol is 1.36. What is the speed of light in ethanol? So we will know over here 1.36. And then the speed of light in the vacuum there. It's a radius to 8 meters per second. And then over again is equal to C over ds, which is the velocity of light in our substance. And that's what we're looking So 1.36 equals 3 times 10 to the 8 plus. Cross multiply. We go back to the piece of that equals 3 times 10 to the 8 over 1.36. I'm getting 2.2 times 10 meters per second. It should always be less than 3 times 10 to the 8. But it should be a whole lot less, because something like ethanol, a liquid or a gas or something, is not going to slow light down hugely. The words number 3 in the class, it's just talking about the thermodynamics of the mirror. Down here, numbers 4 and 5 are talking about lenses, but the math works exactly the same as it did for mirrors. So, a converging lens, for the record, a converging lens is a convex lens, has a focal length of 20 centimeters. If an object is placed at 75 centimeter line from the lens, where will its image be formed? So, that equals 20 di, no, not do equals 75. We are looking for di. Sorry, confused myself there for a second. I didn't want to. Well, I'm here to confuse you guys, and lost my pen in the process. That's nice. Switching colors. So we're looking for di, and just like we did with mirrors, it's 1 over f equals 1 over dO plus 1 over di. Remember that dO is always a positive number. Always, 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 always. So we have 1 over 20 equals 1 over 75 plus 1 over di. Subtract 75 from both sides. We have 1 over 20 minus 1 over 75 equals 1 over di. I do not feel like finding a common denominator for this, so I'm going to plug this whole thing into my calculator, and I get 0.037 equals 1 over di. Please, please, please don't sorry, don't stop here. This is not your answer. So my calculator, I'm going to do 1 over 0.37. And I get that di is 27.03 centimeters. This is a positive number, which means it is a real image. And if the object in number 4 is 15 centimeters high, what is the height of its image? So we know DO is 75, DI is 27.03, HO is 15. What is chi? Formula for that is DO over, and I'm just going to write it backwards. H, let me just scroll everywhere. So it's Hi-Ho over Dido. I don't know why it's so hard for me. HI over HO equals negative DI over DO. Remember to include that negative. So we have HI over 15 equals negative 27.3 over 75. So if you cross multiply, you get 75 HI equals is negative 405.45 divide both sides by 75. And you get negative 5.41 centimeters. The fact that it's negative means that it's inverted, which matches up with it being real. These two should always have opposite signs. Keep that in mind. It's important. Okay, geez, finally got everyone out of my room. So I'm working the problems that are on page 6 of the packet. There are 3 that we didn't work in class, 1, 2, and 7. I believe that we actually worked 1 and 2 as like bell ringers or something, but whatever, it's fine. We're going to work them again. Number 1 says a block of unknown material is submerged in water, which has a index of refraction of 1.33. Light in the water is incident on the block at an angle of 43 degrees. The angle of refraction in the block is 37 degrees. What is the unknown material's index of refraction? So here's our setup. We have the water. That's our incident material. We have unknown block. That's our refracted. Comes in at 43. So that makes theta I 43. Wow, you can't see what I'm doing. Sorry, guys. Then it gets bent back towards the normal line, 37. So theta R is 37. We're told that Ni for water is 1.33. I'm really looking for NR. So we know it has to be greater than 1 because indexes of refraction are always greater than 1. But here we should actually know that it's bigger than 1.33 because it's a solid block, so it should have a larger index of refraction than water. And also the fact that it's forcing the water to bend even more, or it's forcing the light to bend even more, means that it's slowing the light down even more. So, Ni sine theta I equals Nr sine theta R, 1.33 times the sine of 43 equals Nr times the sine of 37. Calculator, 1.33 times sine 33, no, 1.33 times the sine of 47 is 0.97. Then the sine of 37 is 0.62. So Nr is 0.97 over 0.62. Nr is 1.56. So yes, it's not only greater than 1, but it's also greater than 1.33. Yay! Problem 2. How fast will light travel through a material with an index of refraction of 1.62? N is 1.62. C is 3 times 10 to the 8th. We're looking for V sub s, or the speed of light in this medium. We know it has to be smaller than the speed of light. Always is. That is the speed limit for the universe. Cross multiply. 3 times 10 to the 8th divided by 1.62. And I'm getting 1.85 times 10 to the 8th meters per second. Ta-da! All right. Last but not least, number 7. Number 7 says a convex lens with a focal length of 10 centimeters produces a virtual image of an object 12 centimeters from the lens. Where is the object located? So, several things. F is 10. Guys, if the focal length is negative, it's going to give it to you in the problem as a negative. You don't have to worry about figuring out whether it's negative. The one you have to worry about is DI, which is what this is, because it's where the image is. And here's the key word. If it tells you it's a virtual image, then DI is a negative number. We're looking for DO. As we talked about in class today, DO can never be a negative number. This must be positive. Exclamation mark. So if we get a negative number for our answer, we know we've done something wrong. So let's look at setting it up. 1 over 10 equals 1 over 12, 1 over negative 12, plus 1 over DO. So that's 1 over 10 minus 1 over negative 12 equals 1 over DO. 2 negatives makes a positive. I could do that math, but I don't feel like it. So I'm going to plug that into my calculator. I am getting that 1 over DO is 0.0183. Repeating, not my answer. Not my answer. My answer is 1 over 0.183. And I am getting that DO is positive 5.46 centimeters. Has to be positive. O's have to be positive. Have to. So just kind of to summarize for a minute, F can be positive or negative, but the problem is going to tell you. It's going to give it to you as the correct sign. DI can be positive or negative, and you have to figure it out depending on whether it's real or virtual. DO can only be positive. All right, let's move on to the math problems that are on the review. There are not very many. The review consists of a lot of talking about mirrors and images in conceptual terms, which is definitely a good thing to review because there are questions like that on the test, and that's not what we spent our class time on because it's not what people tend to struggle with. But there are 2 math problems here, and we'll look at labeling that diagram. And then there's 2 math problems here that I will work as well. I'm actually not going to work the 4 diagram problems on here because, guys, they are identical to the problems on the other handouts that there are already videos about. If you're still struggling with those diagrams, go watch those videos. That's not what this one's for. Their complaint was rightfully made that we hadn't spent nearly enough class time on this math. So that's what this is about. All right. A ray of light has an angle of incidence of 25 degrees upon the surface of a piece of quartz. If the angle of refraction is 15.9, what is quartz's index of refraction? So here's the setup. There. Quartz. Can you actually see what I'm doing this time? Yes. This is I. This is R. It's coming in at like 25. And then it's getting bent to 15. You can't really tell in my picture, but that's a pretty significant, from 25 to 15, pretty significant bend there. So because this is 25, and that's in air, that's theta I is 25. The 15.9 is down here in quarts, so that's theta R is 15.9. We know that Ni for air is just 1. We are looking for Nr. Ni sine theta I equals Nr sine theta R. So 1 times the sine of 25 equals Nr times the sine of 15.9. Sine of 25 is 0.42. And then Nr times the sine of 15.9, 0.27. And we just divide. And we get that Nr is 1.56, which is very similar to what we got for Nr on that other problem. So perhaps that mystery block was actually made of quartz. All right, number 5. The index of refraction for antimony trioxide is 2.35. How fast will light travel through it? Well, for one thing, this is the largest N value we have seen yet. N equals 2.35. So whatever antimony trioxide is, it super slows down light. So C, or the speed of light in a vacuum, is still 3 times 10 to the 8 meters per second. We're looking for whatever the speed of light is in our new medium. N equals C over V sub S. 2.35 equals 3 times 10 to the 8th over V sub S. V sub S equals 3 times 10 to the 8th over 2.35. And I'm getting 1.27 times 10 to the 8th meters per second. So it's still 10 to the 8th, still very large, but a significant decrease because this N value is as large as it is. All right, so let's look down here at all these things you're supposed to know. Some of these aren't things that I've stressed, and they're not really a big deal. So this is the center of curvature. It's basically the radius of the circle the mirror would make. This is the focal point. It's the point that the mirror is trying to bring all of the light to. All the light rays go to the focal point. Sorry. It's also halfway between the center of curvature and the mirror. The principal axis is just the line that our dude always has to stand on. This line in the center, that's the principal axis. The vertex is here where the mirror is. Again, I don't think those are things that you need to care about. And then the focal length and the, whoa, my light's just, okay, sorry about that. So the focal length and the radius of curvature are directly related to the focal point and the center of curvature. It's just this distance and then this distance. So that stuff's pretty self-explanatory. Not real worried. Do spend some time looking at these, make sure you know all of them. I mentioned some of these but didn't stress them, like the idea that security mirrors in stores, those are convex mirrors because they make everything tiny but upright, and they allow you to see like all of the store at one time because they make everything small. It would be inconvenient to have the a security mirror making things upside down, or to be super magnifying one part of the store. So that's why you need a convex mirror for that. Most of the rest of these are pretty self-explanatory. But I just noticed that I'm not sure we ever talked about that. It's B. Hooray. All right. One last mirror problem. A concave mirror has a focal length of 25 centimeters. If an object is placed 62 centimeters from the mirror, where will the image be found? F equals 25. D. Oh, because it's the object. Is 62. You don't have to worry about whether it's positive or negative. It has to be positive. Absolutely has to. No question about it. 1 over F equals 1 over dO plus 1 over dI. 1 over 25 equals 1 over 62. Why am I talking like this? Plus 1 over dI. So that means 1 over 25 minus 1 over 62 equals 1 over dI. Again, not interested in doing that math to find the common denominator. So I'm getting 0.02, we'll round to 4. Not my final answer, guys. Your final answer is never going to be a tiny, tiny decimal number. It's just not. Instead, I am getting 41.67 centimeters. And it's a positive number, which means it's a real image. Part B. If the object is 5.4 centimeters high, how tall would the image be? So that's HO that they've given us, which also cannot be negative. So 5.4, then DO is 62, DI is 41.67, pi over ho equals negative di over dou. So that's pi over 5.4 negative 41.67 over 62. If you cross multiply, that's 62 HI equals negative 41.67 times 60, no, times 5.4, which is negative 225.018. Divide both sides by 62, and you get negative negative 3.63 centimeters. It's negative, so that means that it is inverted. That should make sense because we decided it was real. Guys, these two numbers, di and hi, should always have opposite signs. If one's positive, one should be negative. Do and di should both always be positive, always, 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 and forever. But di and hi, one should be positive and one should be negative, because if di is real, then it's positive, and then hi is going to be inverted and negative. If di is negative and virtual, then hi is going to be upright and positive. Alright, hopefully this will help you guys. I believe in you. You're going to do great tomorrow. It's not as stressful as you think it is.